Let's talk through the worksheet on the mid-latitude cyclone, 5c-5 frontal systems. It kind of looks like alphabet soup here at the beginning, trying to get everything labeled. We've got our typical well-developed mid-latitude cyclone in the diagram. Cold front arching down from the north, letting cold air in behind it. Warm front spinning up towards the north because this whole thing goes counterclockwise. And then the occluded front that forms because the cold front is running over the warm front. That's the highlights that we went through in the notes. Now, the labeling here, you have your air masses and the circled ones. So the types of air masses are the big circled lowercase letters. The fronts are your numbers, front 1, front 2, front 3. And then you have cities in the capital letters, A through F, I guess it is. So those are the letters and numbers you're going to need to answer this. Now, the couple of them I've graded didn't go so well, so I'm thinking we need to go through this. So I'll just have the answer key up here. Try not to let that distract you. I'll try and talk you through why the answers are the answers. So the numbers of the front. The cold front is number 3. The warm front is number 2. And the occluded front is number 1. Now, there's two ways you can do that. The symbols for the fronts are in your reference tables on page 13, so you could look that up. You don't have to memorize it. You don't have to know anything to do that. You just have to look up the symbols. So, icicles, cold front, tipped over sunglasses here, kind of look two of them at a time, looks like sunglasses, that's your warm front, and then the occluded, which is a combo platter. Now, you can tell which way they're going based on the side of the line they're on. So, whatever side the symbol is on, that's the direction they're headed. So this air mass back here is headed toward the right, toward the east, and that creates your warm front. Back here, this air mass is headed kind of down. It's going that way, like little pointy arrows, and this is heading across. The whole storm system moves from west to east. So 3, 2, 1 for number 1. Type of air mass is B, and then C for the next one. So the air masses. Remember, with your mid-latitude cyclone, it starts off with cold air to the north, warm air to the south, and then the whole thing starts to rotate. So this is cold air. C is continental polar air coming down from the north. B is the warm, wet air that starts off to your south and is going to get squeezed and pushed up northward to get the counterclockwise rotation. Warm, wet air is maritime tropical. So you always have the cold, dry air in the left-hand side toward the top. You always have the maritime tropical air, for us, usually coming from the Gulf of Mexico, down in the bottom pie-shaped piece where it's trapped there. Out in front of this whole thing, you also have more cool air. Maybe not as cold as C, but still cool, so I'd call it continental polar as well. So maritime tropical for 2, continental polar for 3. Maritime tropical down here, continental polar over here. At which front is air rising most rapidly? So you have to know your fronts. So based on what we did in the notes, you have your warm front, cold front, and occluded front where things are really rising. Now, rising most rapidly is going to be the cold front. That's one where the cold air comes blasting in. It's heavier, it's denser, it hugs the ground. The warm air hits it, or it hits the warm air, and the warm air is forced up and over the top. So at the cold front, you have rapidly rising air. Which front has an air mass been lifted entirely off the surface? All right, so lifted entirely off the surface. That's the one where you have the cold front running into a warm front, and the warm air in the middle gets pinched off completely. It's going to happen here eventually. So cold front running over warm front. So cold front runs over warm front. Well, it's actually happening right there. It has happened along this line. That's an occluded front, where the warm air gets totally picked off the ground. So it's going to be along front 1 for number 5. Number 6, where are wind speeds the highest? Wind is caused by differences in pressure. Differences in pressure are caused by temperature and moisture differences. It's always one thing leads to another here. So the windiest, fastest changing conditions are going to happen along cold fronts because one side of the line it's cold, the other side of the line it's warm. And this is moving rapidly down through because, well, cold air can push rapidly down through warm air. So in a matter of a couple hours, you're going to go from really warm air to really cold air, and that creates a high wind as a result. So front number 3 is going to have the highest winds. Which air mass is rising over the other at front 2 for number 7? So front 2, we got this fellow over here. There's front 2, the warm front. So which air mass is rising over the other? Is A rising over B or is B rising over A? Those are your two air masses in the diagram. So along this warm front, it says it's headed that direction towards the right, and you have warm air and cold air. Fronts are named for the type of air that's moving into the area. So warm air is moving into where cold air is. So when these two collide, front B, the warm air, is going to ride up and over the cooler air. It's going to try pushing it out. It's going to push it out. It's going to be slow. Warm fronts are slow. So B does the rising over. So wind speeds are highest at 3 for 6. Air mass rising over the other at front 2. B is doing the rising. Number 8, which front is moving most rapidly across the Earth's surface? So of these 3 fronts, cold fronts move the fastest. They have the easiest time because cold air can plow right through warm air with no difficulty whatsoever. Which city is experiencing brief heavy precipitation? So brief heavy precipitation, which front lines up with that? We had one front where it was heavy precipitation, but it lasted a day. We had another front where it was not so heavy precipitation that lasted about a day. And we had the other type of front where it was brief heavy precipitation. If you don't remember, this is when you have to look at your notes or look back at the video. Eventually, hopefully, maybe, possibly, with a little bit of work, you'll remember this. But cold fronts are the ones that do brief heavy precipitation. So front number 3 there, the cold front, is going to give you the brief heavy precipitation. And which city is along it? What's the city? So city D is on the cold front. So city D on the cold front, right next to me, is there. Which city is likely to have overcast skies but no precipitation? That's going to be city C. Why, you ask? Well, it's in warm, wet air. This is your maritime tropical air mass. Warm, wet air, well, if it's got a lot of moisture especially, warm air rises. When warm air rises, it reaches the dew point and makes clouds. Now, these might not be big, scary clouds. These might be just a layer of clouds over the whole area, but C is liable to have some clouds, but no precipitation. Because it is warm, the air can hold on to that moisture, but it doesn't mean it's not going to make clouds when it gets high enough. Probably pretty up there that day. All right, so C for number 10. Skies soon become overcast. Where will skies soon become overcast? So it's clear now, but clouds are coming. So F is clear now. It's in cold, dry air. No fronts near it, and they're all going past it. But it's probably not going to become overcast. E is probably cloudy because it's along an occluded front. D, we just established it's probably rainy and everything else. C is probably overcast, but it's going to be a while before the front gets there. We're going to go with city A for this one. City A is out in front of a warm front by, we don't have a scale, but a fair distance. And remember, these fronts are the ones that were gently sloping at a low angle. And so about a day ahead of time, you're going to start to get clouds, first really high ones. And then as the front gets closer, the clouds get lower and lower and lower and thicker and thicker. So city A is about to become, or is gradually becoming, overcast. Which city have clouds recently moved out? Has it cleared up at? That's going to be city F because it is no longer near a front. The cold front, remember these blast through 50 miles an hour or so. Cold front was back here not too many hours ago. It's gone through. Now that the front's gone, it's going to clear out. So city F for number 12. Number 13, which city presently has heavy precipitation and low winds? Heavy precipitation, low winds. Now, heavy precipitation and high winds would be the cold front. but it said low winds. So warm fronts don't give you heavy precipitation. So we're up here, the occluded front. Because that warm air is totally pinched off and picked up, you get lots of condensation, really thick clouds, lots of precipitation, but it's not terribly windy because to the left of the front, it's cold air. To the right of the front on the ground, it's cold air. So there's not a big temperature pressure difference right at the front. So that's why City E would have heavy precipitation, but not so much wind. And which city is likely to have light precipitation that's going to last for about a day? So we've gone through the other two. Brief heavy precipitation, cold front. Heavy but long lasting with not too much wind, that's occluded front. Light precipitation lasting about a day because it goes pretty slowly forward, that's going to be your warm front. And in the notes, that's what it says, brief precipitation that lasts about a day. So down here at the bottom, A, F, E, B to finish out the bottom of page 1. If you have questions, feel free to leave me comments. I've been trying, since we're remote, to do my best and leave comments on your worksheets. But if you need more information, let me know, people. All right, moving on to page 2. Now this is going to get a little weird because I'm going to have to flip back and forth even more than I was. So, which city is located in a maritime tropical air mass? So we established continental polar, cold air mass. Maritime tropical is always down here in the pie-shaped piece, or pizza-shaped piece. So maritime tropical in our particular location, it's going to be coming up from the Gulf of Mexico or down by Florida. That's going to be your maritime tropical air. All right, I'll just leave it here and read off my page. So forgive me for looking down so much. Number 16, which city is now entering a maritime tropical air mass? So C, previous question for 15, is in the maritime tropical air mass. B is too, just barely. A is going to enter it probably tomorrow. So we wanted which one's now entering it? That's going to be B. So C's been here, B is just entering it, A will be probably tomorrow. 17. Which cities are now entering CP air masses, continental polar air masses? So D just came into it. It was in maritime tropical, but the cold front went over it. And E up here, and honestly, E was probably in a continental polar air mass, but it's entering a different continental polar air mass. So D and E for 17. 18. Which city has a continental polar air mass recently moved into place? So again, I don't know if the wording necessarily helped you out on this one, because I mean, recently, what's that mean? But we're going to go with F. What I mean by that is, not too many hours ago, this front was back here. The whole system was back here a ways. And so F would have been in maritime tropical air. A few hours ago, that front went over. And so recently, it was in a different air mass. So we're going to go with F on that one. That's a little tricky. 19, which one might have a tornado warning? Tornadoes, thunderstorms, hailstorms, strong winds, all the really nasty, scary stuff, that happens along cold fronts. Yes, it's possible for the occasional warm front to give you some thunder and lightning, don't get me wrong, but if you don't want to overthink it, if you see scary stuff, it's probably a cold front. So city D for number 19. 20. Which city is barometric pressure beginning to fall at? So we have cold, dry air here, cold, dry air here, warm, wet air here. Now, B and C are in the warm, wet air. The pressure is pretty low there because warm, wet air has low pressure. Now, with a warm front, remember, they taper. So out in front of it by 300-400 miles, you're going to have warm air way up high. And as the front gets closer, the warm air gets thicker and thicker and closer to the ground. So if you're at city A, the warm air is going to just be peeking over the top of you a little bit. So you're taking cold air out, pushing warm air in, which has a lower pressure. So the pressures are just starting to fall at A. Probably not a lot at first, but it's going to keep falling for the next day or so as that gets closer. So 20 is A. Which city could the pressure be 974.6 and steady? So that's a pretty low pressure. Remember, average air pressure is 1,013.2. So 974.6 and steady, that means we have low pressure. Low pressure is going to be warm air and it's going to be wet air. So we want a city with warm, wet air and it's steady. So it's not going up, it's not going down, it's in the middle of the air mass. So city C is in warm, wet air in the middle of it, more or less. And so that's why it would be a low pressure and steady. For number 21. 22. At which city could barometric pressure be 1023 and steady? So that's a high pressure, higher than 1013 by a fair amount. Steady, so it's not on or near a front. So near the warm front, near the occluded front, near the cold front. F over here. F is in cold, dry air. The fronts are going away from it, so it's going to be pretty steady. So city F. So if you got behind, we are to there. So make sure you have these. Though if you turned it in, I have your papers. I don't know if you kept anything, but homework is about learning. If you just turn it in to get a grade, you're not learning anything. The whole point of this is you're trying to put it up here so we can get it right later on. All right, so 23, which city has recorded a greatest decrease the past few hours, and 24, greatest increase in the past few hours. So decrease would mean you're coming from cold, dry air going to warm, wet air. So that's going to be city B. The warm front has just passed over you, so that would have caused you to have a decrease in pressure. And greatest increase, city D here, the front just went over it. You went from warm, wet air to cold, dry air. And so that's going to be a great increase in pressure. So B for 23, D for 24. 25, which could experience thunderstorms. So which front did I just say could give you thunderstorms, hail, tornadoes, lightning, scary stuff, all that? That's the cold front. Cold fronts do that. The bigger the difference in temperature between the two sides of the front, the bigger and scarier the weather tends to be. The more unstable the atmosphere is. So D, for 25. 26. At which city is a rapid temperature decrease occurring? Also city D, because the cold front just passed it. It went from warm, wet air to really cold, dry air. And so the temperature has probably dropped 10 or 15 degrees in the last couple hours. It's a pretty rapid temperature decrease. 27, where are temperatures just beginning to rise? So if you're thinking B, it's not a bad thought. A over here, the warm air is just starting to sneak over top of it, so they might just be beginning to rise. At B, they've probably been rising for about a day. So A is the better answer, though if you put B, at least you were thinking the right thing. 29, which city probably has the warmest temperatures? Well, it's in the warm air. It's been in the warm air. It's in the middle of the warm air. The warm air is down in the wedge here. So city C for 29. 30, coolest temperatures is going to be in cold air, staying in cold air, nothing but cold air around it. That's city F in the cold air mass back here. Which city are temperatures cooler, B or E? E up here is in a cool, dry air mass, coming from a fairly cool, dry air mass. And B is in your maritime tropical warm one. So if you want cooler temperatures, you're going to want E for 31. And 32, we had to label the diagrams below. One about the rotation of the winds, the other across line XY. Now, it's a low pressure system, so winds go counterclockwise and inward. This is coming down from the north, this is going up towards the north, and because it's low pressure in the middle, the winds are getting sucked into it, so counterclockwise and inward is a low pressure system. So we're going to pick the one that shows that. And across line XY, that's going across to cold front, some warm air in the middle, then across to warm front. So if we look, We want counterclockwise and inward. That's outward. That's clockwise. That's counterclockwise. That's just all inward. We're going to want 3 for this one, counterclockwise and generally spiraling in. And we're going to want 4 for 32. You're going to have a cold front close to X, a warm front close to Y, warm air in the middle, which is going to get pinched and totally picked up to create an occluded front eventually. I hope that helped. I know this is the toughest worksheet, honestly, for weather, because it ties everything together all at once. But the reality is, when you get a test on this material, or in the real world, low pressure systems are where the weather happens. If you look at a weather map, flick on the Weather Channel right now, or weather.com, you're going to see low pressure systems, and that's where they're going to be talking about interesting weather. So understanding these is really the most important thing. It kind of ties everything together. All right, so hopefully that helped with last night's homework, and make sure you check the classroom for today's work.